We're here with Paul Corkery, General Manager of the Advanced Turboprop Engines business and General Aviation and Integrated Systems. You keep expanding your title, but we're here to talk about the catalyst at GE and what GE is doing in terms of environmental compliance for the future and future technologies. Thanks for being with us, Paul.
Hey Ernie, Addison, thanks for coming. Great lead in on in terms of the program Catalyst. First thing is we just pivoted from the development phase into the certification phase. We're getting ready for a first flight. The engine's running great. As we've gone through this process, we're really validating what is the performance against what our models predicted. And what we're finding out is the performance is good. And it's actually better than we had predicted as we go forward. And what do I talk about performance on this aircraft? Number one is powered altitude and fuel burn. So if I can give you more powered altitude, better fuel burn, you can fly faster and you can burn less. And you mentioned about sustainability. So we put out about 15% less CO2, 24% less NO2 as you go forward. But also we're going to be running sustainable fuels on the Catalyst as we move forward over the next year. And as you've seen here in Oshkosh, we're all here looking at some of the trends that are happening in Oshkosh, which is really hybrid and sustainable fuels moving forward. And I think as we brought in the technology of the compressor, higher pressure ratio, burning hotter, single crystal cooled blades, the power turbine, and the FADEC, that positions us really well for where the hybrid market's going to go, where sustainable fuels are going to go. So we feel pretty good about it. In terms of where we're at in the program, just not only validating the performance from all the testing, we finished 30% of our cert test, and we submit about 35% of our cert documentation. So we continue, Ernie and Addison, to move down the path towards engine certification in the latter half of 2022.
That's great. Sounds very promising.
One of the things that we've spoken to other people about is the idea of hybrid. Hybrid works pretty good if you've got a twin engine airplane because one is traditional fuel and the other is the electric hybrid situation. How do you see, everybody's talking about timelines. Mm-hmm. And there's the timeline moving to SAF. Everybody wants to go to SAF, but there's not enough SAF to go around. As we were told just 30 minutes ago, all the SAF that can be produced has already been pre-sold. There's not enough supply. So how do we see this industry evolving? So firstly, twin engine, you've got some kind of an idea with hybrid, but single engine, Oshkosh is really single engine planes. How do we fix that?
So I think there's two paths there. One is the electrification path, the hybrid path. So we think that the Catalyst is actually well positioned for 1 megawatt solution. So 1 megawatt of power. So if you take 1,300 shaft horsepower, convert electrical, take the prop off, put a permanent magnet, it fits nicely into what the electrical needs would be. And I think there's two steps on that path. One is hybrid, where you have a catalyst running a permanent magnet generator, and then you have high switching power conversion, and you distribute it around the aircraft, whether it's single or twin, however that architecture is. And then you have the FADEC, which it allows you to control it. And what the FADEC does is it understands from the sensors what the configuration of the aircraft is, right? So the aircraft is at this set altitude, I'm using the icing system, I'm using the AC system, this amount of bleed. Then it optimizes what's my reference for fuel flow and pitch. In other words, my shaft horsepower for that condition. So instead of the pilot doing all that, and why it's doing that, it's also protecting the engine from over temp, overspeed, underspeed. So it frees up more of the pilot's time. But that digital control system is also an enabler for hybrid. As you electrify the airplane, and battery technology storage will catch up in the future at some point in time, we're positioned nicely with a package where you have that permanent magnet generator and the power converter to distribute electrical power however you need it. But you need a sophisticated control system to make sure that you can control that overall thing. So that's one path that we see. The other one is when the infrastructure catches up on sustainable fuels, right? So we run sustainable fuels on our other engines, as you know, Ernie Addison, we took big engine technology, brought it down into smaller engines. So a lot of this is proven out. We've got experience running these types of fuels. And as I mentioned, we're going to run these fuels into next year. So as we go down the path of hybrid electric, and ultimately I think electrification, you go down the path of sustainable fuels, and as the infrastructure catches up on the sustainable fuels, I actually think timing-wise we positioned pretty well with the engine and the technology that we're coming to. Now in terms, Addison, you're asking about timing. That's a hard one to predict, but we can, in terms of having us positioned to be able to bring the technology to support the industry as it moves down there, whether it's 5 years from now, 6, 7, 8 years from now. But as you see in Oshkosh, the innovation comes out of here, a lot of different ideas. We want to be positioned to keep our hat in the ring, to be able to play in that market as it expands, whether it's the renewable fuels or the hybrid.
Where does GE get its electric solutions from? Is that something that you guys have internally, or is that something you have to acquire?
No, actually GE has a lot of internal experience on motors, generators, power conversion. We have a whole division that's actually dedicated to that I work with. So we bring the engine, and then we integrate it with the generator and the power conversion. So that would be all GE products in that package. That's why we're actually very bullish on how we're positioned with the technology that we're bringing and the timing of actually where the market is going.
As you mentioned that, I was thinking, well, wait 1 second, you guys are huge in diesel electric locomotives. So, there you have a situation where that's a hybrid right there.
Sure. And I think that this is something, whether you're looking at diesel or you're looking at power plants or you're looking at aviation, that's the power that I think we bring to the table. That we reach out and say, hey, we see the market trending on sustainable fuels. We see it's trending on hybrid. Then we go out and work with a different business and understand what the customer needs are to put together that package. And we've done that over the last year. And one of the things was, what's the power level that's going to be needed in this class of aircraft? And it looks like it's around 1 megawatt. Right, which happens to be where we're sitting with one of our engines. And so having that first step of being able to generate the power in a efficient way and be able to control it. I push back on that controls, because that's an important thing, to be able to optimize these systems. Not only the distribution of power, but to simplify the cockpit so the pilot can spend more time flying the aircraft.
It sounds like this is almost, you've got mature technologies in the controls, you've got mature technologies in the power generation, in the engines, but where it all comes in is the integration of the software, it sounds like, to get the control systems done. That's one of the key challenges I see going forward.
Absolutely. How you control this, but I think the biggest thing, it starts with our customer. What does our customer need to differentiate their aircraft in this market? And then we can help them, to your point, and partner with them to provide the solutions that are best for their applications in this market space. So yeah, that one of the challenges certainly would be the control, the voltage regulation, the power distribution would be some of the challenges. But that's something we would partner with aircraft suppliers on.
Yep.
There's a public policy issue that, sort of, as you're describing this, the public policy issue of politicians are trying to virtue signal about green and everything associated with that. What's the risk that the industry faces, not just GE, but the industry faces, that regulations are put out that are just unrealistic? That, like, no one's technology can catch up to where the rules are?
That's a tough question, Addison. I can answer it this way. I know that in Europe, clean aviation is a big push, right? So and we're in the U.S. as well looking at sustainable fuels. I think it's going to be a journey. I think as the technology matures and the needs mature, I think that working with the governments will be part of the process to ultimately certify these. But I think it's clearly going to be a journey as we go down this path. But there's investment. In Europe, we're involved with clean aviation. The catalyst would be a stepping stone as they go into the regional jet market, proving out the technology, like you mentioned at the beginning of this, that a lot starts here, right, in this marketplace, business and general aviation, and it moves from there. I think we're seeing that same thing, and I think the investments that we're seeing with clean aviation in Europe is going down that path where the Catalyst plays that first stepping stone in the megawatt class as you move up into the larger regional jets.
Let's bring it back closer to home and closer to today for a minute. SAF is currently authorized up to 50%. How long do you think it'll take for us to get to 100% SAF use in some of these engines?
Wow, that's a tough question, Ernie. I defer back to you on that. All I can tell you is we're going to be ready for it and being able to burn that within our engines as the market matures and the availability and the blends go up towards the higher percentage numbers. But we feel confident our engines will be able to sustain that. The timing, we'll be ready for it.
Yeah, sounds good. Let's talk a little bit about the technologies and the catalysts that are important to giving you the fuel burn advantage in the near term that gets us partway to the long-term environmental sustainability that we all want to have. Can you highlight for us the keys from the catalyst in terms of which technologies are bringing you the savings?
Yeah, sure. Thanks, Ernie. So I'm going to start with the compressor, and I'll walk through the turbine of the technologies we brought. And again, it starts with, we've done these before in the larger engines, we're packaging in the smaller engine. And this is the step function change that we believe we're bringing to this market that drives the power and the fuel. Start with the compressor. It has variable geometry. What that means is I can change the first two stages on the geometry so it holds the powered altitude, and you're dealing with the stall margin on the compressor. But it gives you 16-to-1 pressure ratio, which is higher than in the class of machines here, which are probably in the 11-to-1 ratios. So we're putting out more pressure out of the compressor. We're coming into the combustor. We run it hotter. Therefore, when we go through the two stages of high pressure turbine, they're single crystal and they're cooled. That's another technology that you wouldn't see in this market segment, but you'd see on the light jets and above. We did 3 stages on the power turbine, the low pressure power turbine, and the low pressure power turbine. The low pressure power turbine drives the prop, so the extraction of that hot gas that comes through there's a lot of technology. So the higher pressure ratio, the higher temperatures, the extraction of that energy at a more higher rate using the analysis that we do creates that fuel burn and power advantage. On top of that, and I mentioned we have a full redundant FADEC. And like I mentioned, all this we've done before in different marketplaces. It's repackaging here. So in terms of our risk going down and developing the engine, we're comfortable with it because we've solved a lot of these in a different market segment. And that I think it gives us, that technology that positions us, Ernie, for the markets and Addison you're telling us about, where we're bringing that step function change. So we're ready as those markets continue to expand in their own right, whether it's sustainable fuels or utility or hybrid electric or whatever it may be.
For certification on the catalyst, you said you were about 30 to 35% done with some of the certification tests. When do you expect certification for the engine?
Yeah, good question. So the certifications, we're about a third there, and we would project the latter half of 2022 for the engine certification at this point.
Okay, great.
Thank you very much.
All right. Thank you, Addison. Thank you, Ernie.